All right, today we're gonna be going over law of cosines, which is 8.2. Before we get started though, I want to do a little bit more in 8.1. The topics in 8.2 aren't that bad. Law of cosines is not too bad. It's very formula related. But back to 8.1 was on law of sines. And we had the problem case. I wanted to do another example. I'm pretty sure we didn't use these numbers on the last problem. Let me double check. Yeah. Alright, so. Let's go with, we are. Given information is angle A. Is 55.3 degrees. Side A is 22.8 feet. And side B is 24.9 feet. So if I were to draw a triangle. I have angle A here, side A is over here. And I'll call this B, so this is. Wait, yeah, that works, they just need to be touching. So that would be C and side C. So we can fill in what we know, this is 55.3 degrees. We don't know B, we don't know C. A is 22.8. And B is 24.9 feet. So recall sine was. We could either do.
Sideways in.
I thought you were saying Siri, I think.
Startle the shit out of me. We can do like sine B over B equals, in this case, we have information about A. Sine A over A, or the reciprocal. B over sine B equals A over sine A. You just wanna pick the one that's most easiest to resolve. The pieces of information we have are, we have angle, we have both of these. And we have side B. So that, using that one is probably the preferable choice. So I'm gonna go with that option there. I'm gonna do sine B. Over 24.9 feet. Equals sine of A, which is sine of 55.3 degrees. Over 22.8 feet. I'm gonna check my calculator is in degrees, it is excellent. If I solve this, I'm gonna get sine B is 24.9 over 22.8. Times sine of 55.3 degrees. And if we work all that out. I'm getting 0.8978678334. This is less than 1, so we may have a second triangle. So to find my angle, I'm gonna do B equals sine inverse of that. And I get 63.9 degrees. Okay, so one triangle we have information for is this. Make a little table. I'll do my angles and my sides here. A, B, C. A is 55.3 degrees. We had 22.8 feet. 24.9 feet. And I just found out that this is gonna be 63.9 degrees. To find out if there is a second triangle. Before we continue, is there a second triangle? We're gonna do 180 minus B. And if I do that, 180 minus that, I get 116.1 degrees. And what I wanna do is verify or check. Are the two angles I have less than 180? Like angle A and angle B2. I'll call that B2. 55.3 degrees plus 116.1 degrees is. Plus 55.3. This is 171.4 degrees. So that is less than 180. We do have a second triangle. There is a second triangle. So I'll kind of like put that in a box. So let's finish our first triangle. How can I get C?
180 minus the angles here.
180 minus those angles, yeah. Angle C will be 180 minus 55.3 minus 63.9. If I do that over here, I'm gonna do that on this one too. 180 minus 55.3 minus 116.1. This one I have relatively quickly is 8.6. And this one over here. 60.8. So maybe I should make a chart for my other information. A, B, C, angle and side. We have 55.3, 22.8 feet, 24.9 feet. Calculated on this one, we have 116.1 degrees and 8.6 degrees. And now to find side C, you want to use the one that has all the information with it. A has all the information, B was rounded for the angle. So to find side C, I'm gonna go with C over sine C equals A over sine A. And I'm gonna do that on both. So C equals A times sine C over sine A. On this one, I have 22.8 times sine of C, which is sine of 60.8. over sine at 55.3. If I set that up over here, I got. The only thing that's changing is. The angle for sine C, it is no longer 60.8. It is 8.6. And I am getting C equals 24.2 feet on this one. And if I do it on this one. 4.15. And again, that's in feet. Yeah. That's another walkthrough of doing this, because this is the harder scenario where there's two triangles. You just have to check to see. If I make another angle B, can I still have a triangle? Angles have to add to less than, or add to 180. And if A and B, your second B are over 180 already, that triangle doesn't exist. So it turns out there's two triangles here. And one of them has a very, very fucking narrow angle. 8.6 degrees is not very, very big, it's some shit like that, you know, very small angle. With a corresponding small side on the other side. It's interesting. It's fun little scenario of triangles. Alright, so one more topic that is in 8.1 before we hit law of cosines. Anyone have any questions on this one? Yeah,
On the second triangle, that two triangles share a point. That they occupy some place in space, or there's another.
it's more like one of the, we had, let's see, we had these two things. Side angle C could have been. Let me redraw this triangle up here a little bit. Where are the pins? Okay. Apparently. This could have been set up. As a triangle, we had angle 55.3. 24.9 there. And this is doing some shit like that, 22.8. And it's making an angle like that. But we don't know if this 22.8 is going this direction. Or if it's going that direction. Does that make sense? So I kind of like drew one where it was an acute triangle. Cause that's what we're used to seeing, but if there is a obtuse triangle. We won't know unless we test the angles. And the angles have to add the 180, which means if two of them already add to more than 180. That third angle can't happen and therefore we don't have a triangle. Okay. The last topic that's in 8.1 is area of a triangle. Now, we all are familiar with, hopefully. Area equals 1/2 base times height. But that is for a right triangle. Right? That's when we have some shit like this. That's B, that's H. And you're basically doing half the area of a square or a rectangle. You're gonna have the area of a rectangle. What happens if it's not an acute triangle? So let's say we have angle ABC. Well, this should still be 1/2 base times height. But finding the height isn't trivial. Because theoretically, if we rearrange the parts of this. We will have half of the triangle, so what I'm gonna do. Is I'm gonna drop a line down and make that my height. That makes nice little right triangles there, this whole length is B. My base. This is angle C, which makes this side C. And that's side A. And if we go off the angles. Like sine A is. Opposite over hypotenuse, H over C. So H equals C sine A. And I can do it over here, sine C equals. Opposite over hypotenuse. H over A. So H equals A sine C. And now we can replace that in our A. So we can have. Area equals 1/2 B. Times C sine A. Or we can have area equal 1/2 B times A sine C. And if you'll notice, the angle that is inside. Is missing on the sides outside. So we have a third option. If we have sine B. I could have 1/2 AC sine B. So let's just do a triangle and find the area real quick and we'll be done with the section. Let's say we have, let's see. Let's call this 9.0 feet. We'll call this 127 degrees. And we'll call this 12 feet. So if this is angle B, this is side B. I could call this angle A. With side A and angle B or angle C with side C. I can just pick however, however I wanna letter them. One of these equations is gonna work. The one we have the angle for in this case is B, so I'm gonna go with this version right here. A equals 1/2. A, which is 12 feet. Times C, which is 9 feet. Times the sine of the angle. And I am getting A equals 67.6. And the units were feet, so area is square feet. Did I do something wrong, Jordan?
Get a different number.
Yeah, I'm getting a different number too.
Let me check my answers here. 12 times 9 divided by 2 times sine 127. Yeah, so am I don't know what the fuck happened. I'm getting 43.1 this time.
Yes.
The fat finger of the calculator. Alright, I'm gonna stop recording on this one and start a new recording for. Part 2.